Building a desktop computer can be a rewarding experience, and it allows you to customize your system to meet your specific needs. Here's a step-by-step guide on how to build a desktop computer. 1. Gather components. Before you start, make sure you have all the necessary components. These typically include 1. CPU, Central Processing Unit, the brain of your computer. 2. Motherboard, the main circuit board that connects all your components. 3. Memory, RAM, provides temporary storage for your computer's operations. 4. Storage, hard drive, HDD, or solid-state drive, SSD, for your data. 5. Power supply unit, PSU, supplies power to your components. 6. Graphics card, GPU, optional, but important for gaming or specialized tasks. 7. Computer case, to house all your components. 8. Cooling system, fans or liquid cooling to keep your CPU and GPU from overheating. 9. Operating system, such as Windows, Linux, or macOS. 10. Keyboard, mouse, and monitor, input and output devices. 2. Prepare your workspace. Choose a clean, well-lit, and static-free workspace. Use an anti-static wrist strap to discharge any static electricity from your body, which can damage sensitive components. 3. Read manuals. Read the manuals for your motherboard, CPU, and other components. This will help you understand how to connect everything correctly. 4. Install CPU and RAM. 1. Open the CPU socket on the motherboard. 2. Carefully insert the CPU according to the motherboard's instructions. 3. Attach the CPU cooler if it's not pre-installed. 4. Insert RAM into the designated slots. 4. Refer to your motherboard manual for the correct configuration. 5. Mount the motherboard. Place the motherboard inside the computer case and secure it using the provided screws. Make sure it's properly aligned with the case's rear I/O shield. 6. Connect power supply. 1. Mount the PSU in the case and secure it. 2. Connect the motherboard's main 24-pin power connector. 3. Connect the CPU power connector, usually 4 or 8 pins. 4. Connect power cables for other components, GPU, drives. 7. Install storage drives. 1. Mount your storage drives in the case, HDD, SSD. 2. Connect data cables, SATA or M2, to the motherboard. 3. Connect power cables to the drives. 8. Install graphics card. If applicable, insert the GPU into the appropriate PCIe slot on the motherboard. Secure it with screws and connect any necessary power connectors. 9. Connect cables. Connect case cables, power button, LED, USB, to the motherboard headers. Refer to your motherboard manual for guidance. 10. Install cooling system. If you have an aftermarket CPU cooler, install it according to the manufacturer's instructions. Ensure that it makes good contact with the CPU. 11. Check connections. Double-check all connections to ensure everything is properly seated and connected. 12. Close the case. Seal the computer case, making sure all cables are neatly managed to ensure proper airflow. 13. Install operating system. Boot your computer from an installation media, DVD, USB, and follow the OS installation instructions. 14. Install drivers and updates. After the OS is installed, install motherboard, GPU, and other hardware drivers. Then, update your OS to the latest version. 15. Test your computer. Turn on your computer and check if it posts power on self-test. If it doesn't, troubleshoot any issues. 16. Install software. Install the software and applications you need for your tasks. The choice between Intel and AMD for your computer's central processing unit, CPU, depends on various factors, including your specific needs, budget, and performance requirements. Both Intel and AMD offer a range of CPUs, and each has its strengths and weaknesses. Here are some key points to consider when comparing Intel and AMD. 1. Performance. 1. Single-core performance. Historically, Intel CPUs have often had an edge in single-core performance, which is crucial for tasks like gaming and some single-threaded applications. 2. Multi-core performance. AMD Ryzen processors, especially those from the Ryzen 3000 and 5000 series, have competitive multi-core performance, making them great for multitasking, content creation, and certain workstation tasks. 2. Price. 1. AMD CPUs generally offer better value for the money in terms of core count and multi-threaded performance. 1. You can often get a more powerful AMD CPU for the same price as a comparable Intel CPU. 3. Integrated graphics. 1. Many Intel CPUs come with integrated graphics, which can be useful if you don't need a separate graphics card. 1. AMD's Ryzen G series processors also offer integrated graphics. 4. Compatibility. 1. Intel CPUs have historically had better compatibility with a wide range of motherboards and components, particularly for workstation and server builds. 2. AMD has improved compatibility significantly, but you should still double-check motherboard and RAM compatibility, especially with older chipsets. 5. Power efficiency. 1. AMD's Ryzen processors based on the Zen architecture have made significant strides in power efficiency and are competitive with Intel in this regard. 6. Thermal design power, TDP. 1. TDP values can be a bit misleading. 1. Intel and AMD calculate TDP differently, so it's important to look at real-world power consumption and heat generation for accurate comparisons.